Hello all, my name is Meenachi Sundaram, Assistant Professor, Department of Mechanical Engineering, Sedu Institute of Technology. So today I am going to discuss about the topic on operation research assignment model. So what is meant by assignment model? So assignment problem is one of the special cases of a transportation problem. The objective is to minimize the cost or time for completing a number of jobs by a number of persons or machines. So in which the single job is assigned to single machine or single person only. So here two types of problems are available. One is balanced assignment model. So in which the number of rows will be equal to the number of columns. That will be square matrix. Another one is unbalanced model in which the number of rows and the number of columns are not equal, in which we are going to add a dummy row or dummy column with zero value. So it will not be affect the original costs. So this assignment model is going to solve with the Hungarian method. So we are going to discuss about the step-by-step procedure. So first step is you are going to note down the row minimum values. Second step is column minimum. And next step is assign 1 0 in each row and each column. Next step is check for optimality. So in optimality, we are going to verify the number of steps each one by one. We are going to discuss in the problem. So if each row and each column having exactly only 1 0, then the solution reaches optimal. If not, we are going to follow these steps. First, mark the rows that do not have assignments. Then next, mark the columns that have zeros in marked rows. And then mark the rows that have assignments in marked columns. So next, we are going to draw lines through unmarked rows and marked columns. And then we are going to select minimum theta, and we are going to add theta on double lines, subtract theta on no lines, and no change on the single lines. So this is the step-by-step procedure in Hungarian method. So after that, we are going to once again repeat the step 3. So here is one example problem how we are going to use the Hungarian method. So consider the assignment problem as shown in the table. 5 different jobs to the 5 different operators. So in which to minimize the operating time. So this is the given problem. So number of jobs 1, 2, 3, 4, 5 and number of operators 1, 2, 3, 4, 5. So each will be given as the cost matrix. So 5 cross 5 matrix. So our first step is to check whether it is balanced or not balanced. So it is 5 cross 5 matrix, therefore this problem is balanced one. We are going to step 1, so row minimum. So this is the given problem in which each row we are going to note down the minimum values. So first row 8, second row 7, third row 7, fourth row 10, fifth row 8. And then we are going to redraw this table. So we are going to subtract first row with 8, second row with 7, third row with 7, fourth row with 10 and last row with 8. So this is the redraw table with row minimum values. Second step is column minimum. So here the last drawn table in which we are going to note down the column minimum values. So first column 0, second column 0, third column 0, fourth column 2, fifth column 0. So again we are going to subtract the first column value with first column. second column value with second column, third column value with third column. So in which 0 it will not affect the original values, and fourth column we are going to subtract with 2, and last column is 0. So in which the fourth column only will be changed, other columns will be as same numbers. So this is second step. And next step is we are going to assignments. So this is the last drawn table. Again we are going to redraw this table. So here we are going to assign zeros in each row and each columns. So we are going to start with the first row. So first row we are having one single 0 we are going to assign. Immediately we are going to corresponding column zeros are cancelled. Yes. Next second row is single 0 we are going to assign, corresponding column 0 is cancelled. And third row we are going 2 zeros, so we are going to skip this third row and going to fourth row having only 1 0, so we are going to assign corresponding column no zeros. So last row no zeros. So again once row completed we are going to start with column. So first column already assigned, second column already assigned, so third column single 0 we are going to assign, and corresponding row zeros are cancelled, so corresponding 0 is cancelled. So fourth column no zeros, fifth column already assigned. So again repeat with row 1 2 3 4 5, again repeat with column 1 2 3 4 5 if the number of zeros are more number of zeros available. So in this problem we are going to assign 4 assignments only, but we are needed in 5 assignments. So the solution is not reached optimal. So we are going to step 4 optimality condition. So this is the already shown in the step 3 itself. So after that we are going to tick whether first row is assignment, second row assignment, third row assignment, fourth row assignment, and last row only not having the assignment. Therefore we are going to mark this row, and marked row having 1 0 that is in the first column we are going to mark that column. After that the marked column having 1 assignment, that is second row, we are going to mark this second row also. So this is the tick mark. After that we are going to draw lines through unticked rows. So first line, first row, third row, fourth row, these rows not doesn't having tick marks, and we are going to draw lines through ticked columns. So first column only having tick mark, therefore we are going to draw line. So after that we are having 8 values 9754 5717, in which the minimum value is 1, that is going to taken as theta is equal to 1. So next step we are going to redraw this table. So how we are going to draw this table with the 3 line methods. So first one is double line. If double line occurs we are going to add theta. So 2 plus 1, 6 plus 1, 2 plus 1, and single line passes then no change. So 0 here, 0 here, 4 7 2 0, and third row 7 0 0 2, and fourth row 0 1 1 0, and remaining cells are no lines, therefore we are going to subtract theta. 9 minus 1, 7 minus 1, 5 minus 1, 4 minus 1, 5 minus 1, 7 minus 1, 1 minus 1, 7 minus 1. So again we are going to repeat the optimality assignment step. So first row having 1 0 we are going to assign, immediately we are going to cancel the corresponding 0 in the column. Second row single assignment, we are going to corresponding column 0 cancel. Third row 2 assignment 2 zeros, therefore skip the third row. We are going to fourth row single 0, corresponding column no zeros, and last row we are having single 0 we are going to assign, and corresponding column is cancelled. So once fifth row is completed we are going to start with first column. First column is already having assignment, second column already having assignment, Third column is having single assignments. Corresponding row is already cancelled. Fourth column is assigned. Fifth column is assigned. So now we are going to check 5 assignments are there. So the solution is reaches optimal. Therefore, we are going to stop this Hungarian method and we are going to the result part. So this is the result. So job 1 will be assigned to 5, job 2 will be assigned to 1, job 3 will be assigned to 3, job 4 will be assigned to 2, and job 5 will be assigned to 4th operator. So the corresponding time will be in the original problem. So first job 5th operator is 8, second job first operator is 7, corresponding fifth job 4th operator is 11. So the total time is 43 hours. So this is the assignment model problem. Thank you all.